Okay, question 3, the table at the bottom of the problem gives you a bunch of data, right? It contains monthly data on production levels and production cost. When you make product, right, the more you make, the more your costs go up, right? Why do your costs go up if you make more product? My wife went to the bakery this morning, apparently it was the best bakery, best donuts in Brooklyn. And I know where the best donuts are. I mentioned this in my microeconomics class today. The best donuts that I've ever had are in a little hole in the wall dive bakery called Fresh Donuts. It's on State Street in Salt Lake City, Utah. State Street is a 5-lane road that goes from downtown Salt Lake to Draper, Utah. Straight road. It used to be the old highway, but it was near our house. And when you went in there at 8 o'clock in the morning, the donuts were still warm from being cooked. And they just melt in your mouth. If I was in my 20s, I'd probably eat 10 a day. Because I'm in my 50s, I would only eat 1 a week. Even though I wanted 10 a day. So I compared these donuts to my wife's, the ones that my wife bought with the donuts in Utah. And I tell you what, the best donut in Brooklyn comes nowhere near as good as those because of the freshness. When they come right out of the oil and they got the goo on there and they're still warm and gooey inside, ain't nothing better than that, right? So the more donuts you make, why do your costs go up? Why do your costs go up if you make more donuts? You have to have more flour. You have to buy more flour, right? More sugar, more employees, more hours working your given employees. You might have to, if your output, if your demand is really, really high, you may want to rent the store next to you, right? You may knock down the wall in between 2 stores and then rent that bigger space, right? So that's why costs go up as you produce more, right? So in this one, we have production levels with production cost during a 4-year period for a company that produces a single product. So this could be Tom's lobster rolls. Have you guys been to Tom's lobster rolls? How many people like lobster? You got to find Tom's lobster rolls. They're over by, I think, underneath in the area where the Manhattan Bridge comes in from Brooklyn. They're in Manhattan. It's in Manhattan. It's a hole in the wall. The restaurant has an L-shaped table that's only like 10 inches wide. People cram in there to get their lobster roll. Only get the lobster roll. Don't get anything else. Don't get the crab roll, just a lobster roll. The lobster is fresh out of the ocean. Like 8 hours earlier, the lobster was in the ocean. It's that fresh, right? Small store, right? I don't know why I started talking about lobster rolls. I forget. Okay, because that company, for the most part, produces a single product. Fresh lobster, steamed lobster, in a Texas toast kind of like bun with like butter, and that's it. Killer product, right? A 1-product firm. Do simple regression on all the data to see how total cost is related to units produced. Use a resulting equation to predict total cost. So we're predicting total cost, right? Our Y variable is total cost because that's what we want to predict. We want to predict total cost in month 49. Given that the proposed production level for the month is 450 units, right? So if we're producing 450 units, we want the total cost in month 49. Do you see anything wrong with the analysis? How should you modify your analysis if your main task is to find an equation useful for predicting future cost? And you know that the company installed new machinery at the end of month 18. What does new machinery do to your productivity? Why'd you buy the new machine? What? Why would you buy the new machine? Why would any company want to buy a new machine, like a robot? More efficient. More efficient, more productivity, right? your current employees are going to be more productive. And if your current employees are more productive, they're probably going to get higher pay, right? So as productivity goes up, pay tends to go up too. So this is good for employees, in my opinion, right? So when was the new machine purchased? When was the machine purchased? At the end of what? At the end of month 18, right? So let's copy the data into Excel. So go to the bottom of the model of the problem. When you copy data into Excel, what do? You grab the S from submit, right? You grab the S from submit, you right click on the blue, copy, and then you come over here to A1 and you do what? You paste matching destination formatting, right? Right click in Excel in A1, match destination formatting, right? Everybody got that? Delete the S. Okay, in column 1, what do you have? In cell A2, what do you have, Annalena? What do you have in cell A2 when you copy the data in? Are you doing the problem? You got to copy the data in, right? Okay. Julie, what do you have in cell A2? 1. What do you have in cell A2, Emmanuel? 1. What do you have in cell A2? Are you there yet? Yep. 1. Jacopo, what do you have in cell C2? C2. What do you have in C2? Cell C2. Oh, you're pasting right now? Oliver, what do you have in cell B1, 2? Yeah. Okay. And then Jane, what do you have in cell C2? Okay, so everybody's got month, Annalena, in A1. Units produced in B1. And then total cost in C1, right? Everybody's got that? Everybody's got it? We're good? Yeah. Woo, woo, woo! Yay! We got it? Okay. All right, so what are we going to do here? Use Excel to estimate a regression for all time periods, and then estimate one that uses data after the machine was installed. So we're gonna do the regression for all 48 time periods, and then we're gonna do one that follows the implementation of the installation of the new equipment, right? So the first thing I want you to do in Excel is highlight, click on cell B2. Don't double click it. One click on B1, B2. Don't double click it, right? You don't want to be inside the cell. Don't have the cursor blinking inside the cell, right? Everybody's got the cursor on cell B1 or B2? Okay. Have we got it? Oh, you don't got it? Oh, you want to close it and reopen it? Oh, this is a good time to save it, right? If you close it, it might reopen it saved. Wait, Microsoft. Good. You want to be right here? Are we there? It's on cell B2. All right, what happens if I hit the shift button? Or is it shift? What happens if I hit the shift and the down arrow? I go down 1. What happens if I hit control shift together? If I hold down control shift, and do the down arrow, what happens? Well, the data is highlighted, right? Everybody highlight everything in column B except for the name. And then release the control shift button and just hold down the shift button. Press and hold the shift button and then hit the right arrow key. It should highlight everything from B2 down to C49, right? Well, are you using a Mac?
Yeah.
Okay, so what you want to do is you want to, I think, Command and Shift. Hold Command Shift down. So you're holding Command Shift down, right? And hit the down arrow once. And then hit the right arrow one.
Okay.
You got it? So everything's highlighted, right?
Yeah.
Okay, now we're going to do a scatter plot. I'm going to insert a scatter plot. Okay, everybody see the scatter plot here? Now this is kind of uninteresting, right? I'm going to set this aside. When was the machine introduced? When was the machine introduced? Was it week or month 18? Month 18, right? So the machine was introduced at the end of month 18, right? So now what I want you to do is I want you to click on cell B20 and then repeat what we just did. B20, down arrow, hold down the Control Shift or Command Shift. Highlight everything from cell B20, which corresponds to month 19, all the way down to C49. Have we got that?
Yeah.
Okay. And then click Insert and Scatter Plot. Oh, look at that. Look at that there. Compare the two. What do you notice? What do you notice there? Are these points here? These points down here? Yeah. So let's do this. This is total cost. I'm going to change the title to total cost month 19 to what, 48? Well, the last month is 48. Okay. Making sure. Total cost, I'm going to put that in parentheses, right? Every step. When I click on that chart, it shows me it's from month 19 to month 48, right? And it looks different than this, right? It looks different than that one. Okay, in this one, what I'm going to do in this one, I'm going to change this. I want you to click on one data point right here. Click on one data point and then go to the very bottom. I want you to grab that bottom right-hand corner, turn your cursor from a white plus to a line with arrows going in both directions on a 45-degree angle. Click and hold the left mouse button until you get to row 18. See that? And then do the same for the purple box. And we're going to compare these two. Okay. So this one is total cost for what months? 19 down to 48, right? And the other one is total cost for what months? 1 to 18, right? Now, this is the cool part. You guys ready to, are you guys, just watch real quick. Everybody watch. I'm going to overlay one on the other. Are you watching? Are you ready to go? Ooh. You guys ready to do that? Ooh. All right, here we go. I'm going to do Control X, and I'm going to click on this in the white area. And I'm going to do a Control V. Are you ready? Jacopo, you watching? Are you watching? All right, watch. Jacopo. Oh, what happened there? Orange dots are what? The orange dots are from 19 to 48. What are the blue dots? Isn't that cool? Sweet, huh? This is why I say I'm a creative quant. I'm not creative when it comes to artwork. I can't draw a painting. I draw a tree. It's got green leaves and a brown trunk, right? I don't see trees being brown and orange. I see them as green and brown, right? Green leaves, brown trunk. I'm not an artist, but I'm a creative quant. I'm a creative quantitative person. I'm creative in my quantitative skills, right? This tells a much better story, doesn't it? Right? It tells a much better story. Why do we do that? Because it's going to help us with this problem, right? How do you make them? How did I make it again? Yeah. You got the two charts? Yeah, one for both. Yeah, one. Everybody have one chart for both time periods. Hey, this is cool. You can't go back in time. A time machine won't take you back in time, but a time machine can take you into the future. You just got to find a black hole and then orbit it with a spaceship, right? So you have to find a black hole. You orbit that black hole, you can go into the future, right? Have you guys seen Interstellar, the movie? Okay. I love physics. You can't go back in time, but in Excel, you go back in time. I'm gonna hit Control Z. Control Z. Look, right. Control Z. Okay, I got the two charts here, right? I got the one for 19 on, and I got the one for what? 1 to 18, right? Everybody see it? Everybody, woo! I got the two charts, right? One. I got the two charts. I'm going to hit Control X. For Jacopo, you want to do Command X. Do Control X. Get rid of one of them. On the other one, you want to just click anywhere on the white area right here. And then once you've highlighted it, like you got these dots on the corners, right? You Control V. What do you have to do? Yeah. Yeah, one is for 1948, right? The other one is 1 to 18, right? I got two charts originally, right? One is 19 to 48. The other chart is 1 to 18. Right? You got two charts. Now you want to get rid of the 1 to 18 one. So you do Control X. All right, let me come around. As my mom said in her deathbed when she's got a cancer, I'm like, PhD. In her deathbed, hospital. And I spent thinking her last 2 days of her life in a hospital. And she wanted ice cubes in her mouth. And so I put ice cubes in her mouth. She always say ice in her mouth. Even in death, she just wanted her own. Oh, yeah. Look at it. So oh, they are. Yeah, okay. Yeah, they're different. Okay. Yeah, we can change it to us. They got you. Yeah, cool. Yeah, you guys are getting sick.
I put control C and then it's a lead in the middle.
Okay, so I just did. So then, oh, there you go.
Okay, that's 118.
Yeah, and then I just start that, and then you can move it up.
Oh, okay. Thank you.
Yep.
19. You got one for 1948, right? Yeah. No, we didn't. That's what it is. Oh, yeah. Oh, yes. Yeah, command. Oh, here we got it. We got two great scatter plots embedded in each other. This is what analytics is all about. Telling interesting stories with data. Making it easy for bettors to see what's going on. So you have two charts. Okay, let's do this. Control C. Okay, that. Oh. Okay. 1948 and 118. Right? Control X. Control. B as a victory. B is in victory, not void.
Yeah, we understood B.
Oh, okay. You heard B. Or you heard B. Okay, cool. Awesome. B too. Yeah, you heard. I talk fast, and my B and V sound a lot alike. Okay, so now what we're gonna do is we're gonna do this. Check this out. Click on a blue dot. Everybody click on the blue dot, and then right click, add trend line. And then go to the very bottom and click on display equation, display R square. I'm going to color this blue because the dots are blue, right? I'm going to change this down here to red. I'm going to change these to red. You don't have to do this if you don't want to. Right here on the blue ones or the top ones, the top set of dots, right click, add trend line, right? Display equation, display R square. And then if these are blue dots, if these top dots are blue, change the equation to blue, right? I'm going to change these bottom ones to circles. I'm going to change them to circles. I like my dots to be circles. And I'm going to change the color to red. Okay, so I got blue dots. Blue dots are my top dots. Red dots are my lower dots, right? I can change the blue line to, or the black line to blue. See that? I got a blue line, blue dots, blue equation, right? Right click on your lower set of dots. Right click on your lower set of dots, add a trend line. I'm going to change that color to red. And then I'm gonna go down here to the bottom. Whoops. I'm going to click on display equation in R square. I'm going to make this red. I'm going to make the font red. Okay, what do you notice here? Notice Notice that my R square is really close to 0 here. Why is the R square really close to 0? Look at this R square, 0.4748. What's going on here? Before the machine is put in place, there's a lot of variability, isn't there? The old machines had variability in the process, didn't it? The new machine makes us more efficient, lowers our cost. It lowers our cost, right? Lowers our cost. And notice the spread. Look at my lower dots. Are they closer to the red line? See how close they are to the red line? Look at the blue dots. Aren't they spread out more? Why? The old machine was rickety, old technology, put defects in the product. The new machine is very efficient. It produces more at a higher quality. Think about humans filling up coffee cups at a coffee shop. Are humans always going to get it at 20 ounces? Are they going to fill it exactly to 20 ounces every time? Humans? What about a machine? Is a machine going to, as a robot barista, if you set it to fill to 20 ounces, is it going to be really close to 20 ounces? It's going to be really close to 20 ounces, right? So if you replace human baristas with robot baristas, your product quality, there's less variability in your product quality. The same amount of sugar is going to be added. The same amount of cream is going to be added. The same amount of coffee is going to be added. There's going to be more consistency. And you see that, right? My red dots are closer to the line. Notice my red line is lower than my blue line too. The height of the points is the total cost. So the new machine does what to my total cost? Lowers my total cost, right? Yep. All right, so moving on. Now we got to run the regressions, right? So I got to do regression results when all of them n equal 48, right? So what I want to do here is everybody click on the data tab. Did everybody click on the data tab? Now, Jacopo, you might not. Hopefully you have this. Do you have a data tab? Okay. Does everybody have data analysis out here to the right? How many people, when they clicked on the data tab, have data analysis out here to the right? You might have to maximize your screen. Yeah, you click on the data tab. Juan, do you have data analysis out here? Emmanuel, you have data analysis?
I don't have so.
Oh, that's fine. Solvers later.
I don't have it.
Okay, so if you don't have it, this is what you have to do. Click on File. When you click on File, do you see options at the bottom? If you don't have the data analysis option in the data tab, you want to click File, and then at the bottom, you should see options. Everybody click on options that doesn't have data analysis in their ribbon. You should get this menu here, right? Excel options. Everybody got the Excel options? Okay. Now down at the bottom here, it says add-ins right here in the left bottom. Add-ins. Click on the add-ins. Click on the add-ins, everybody. We're good? Add-ins. And then down here, does it say Excel add-ins right here? Have we got that at the bottom? Hit go. Go for it. Ted, go for it. We want to check analysis tool pack and solver because we're going to use solver later. Maybe. We're kind of running out of time. Analysis tool pack and solver. Next spring, when I teach this class again, students will have gone through my business quantitative methods class, where a lot of the stuff early in this class will be taught in that class. And then this class we'll review that stuff more quickly and get into the more advanced modeling stuff. I'm not sure if we're gonna be able to do that this semester. And then just hit OK. When you hit OK, do you see data analysis over here now? Everybody got it? Yeah. Jacopo, you got it? All three got it?
Oh, you got it? Okay. You gotta. You, captains, so. I don't know. Okay. Simply. Okay. It's okay. Yeah, good. You like this one? That's fine. I don't think they're gonna get the solver. The solver tool is really cool, man. That's this. Huh?
I need for the server.
Oh, Adams. And click it and then go down here to go. And then you split it over. Whoop, click it. Hit okay. Don't go, you should see both of them. We might be able to, we might not have time to get to the solver. It's a really cool tool though. All right, so now that we have data, click on data analysis, and you should get this menu. Everybody got that menu? Find regression. Do you guys do linear regression and stats? Do you guys do linear regression and stats? Matt 330? No? What about business quantitative methods or business calculus? No? In there, did you guys do regression? Okay. We should have. You got to do regression in this, right? So now, if you haven't done it before, you're gonna see it here, right? So did everybody click on regression? Everybody clicked on regression?
Yeah.
Okay. And then hit OK. You'll get this menu, right? What are we predicting here? What's the thing that we want to know? It told us in the problem, right? What are we trying to predict here? What are we predicting? Total cost. So that's our Y. So I want you to click on cell C1, right? Click on cell C1. So it has a dashed lines around it. And then what are you going to do? Control Shift, down arrow. Whoop, I guess not. All right, so what you have to do, yeah. So let's do that again. You have to do it with the mouse. Yeah, you have to do it with the mouse. Okay, so in input Y1 or input Y range, click and hold the left mouse button and then go to the very bottom. Okay, and then you should have C1 to C49, right? C1 to C49, right? For the X range, what do we do? For the X range? Yeah, units produced, right? Including the name. So B1 down to B48. Or 49, sorry, 49. So this should be C1 to C49. This should be B1 to B49. And then why do you want to click labels? Yeah, you had the labels, the names, right? The names of the values, right? And then just hit, oh, and we want to keep it on the sheet, right? So you want to click on output range. Whoops. What happened? Oh, there it goes. Click on output range. And then over here, click on the white box. Does everybody have the cursor blinking in this white box for the output range? You want to click on that because if you don't, it'll mess this up in here. I don't know. It's a thing that has been Microsoft Excel since I can remember. So you click the output range, click the box, and then you go over and put it in H1. We'll put it in H1. We're going to click on H1. If everybody has H1 here, everybody has C1 to C49, B1 to B49, labels, and then output H1. H1 right there, right? Everybody got it?
Oh, you did the H1.
Well, you click on output range. Then you put your cursor, you want it blinking in here, right?
Yeah.
Then you just click on H1. The first part of that is sheet 3. We're in sheet 3, right? So we have sheet 3 H1, right? Not working. What did my mom say when I put the ice in her mouth? Guys, kids smile, go, you're doing it wrong now. You're doing it wrong. Yeah, right here. So it's blinking, and then click on H1. H1. Okay. Yeah, just ran a regression. Just ran a regression, right? Did okay, right? Did everybody click OK? Clicked OK? Okay, let me shrink this up or skinny it up. How many decimal places do we want? We want 4 decimal places, right? So what I'm going to do is I'm going to hold down the control button. I'm going to use my mouse, click on numbers with decimal places. See that? I'm holding down the control button. Numbers with decimal places. See that? I'm numbers with decimal places. I'm highlighting all the numbers with decimal places, not the integers, right? I'm holding down the control button. Hold down the control button and then click on the cells that need to be rounded. Everybody got it? And then I'm going to go up to home. I'm going to shrink the number of decimal places to 4. I want 4 decimal places. I want 48 here to have 0 decimal places. I want 1 to have 0 decimal places. I want 46 to have 0 decimal places, and I want 47 to have 0 decimal places because those are counting numbers, right? They're integers. I'm going to widen out column H. I'm going to widen out the other columns. All right, we don't need the confidence interval. I'm going to delete the confidence intervals. See the confidence intervals right here? I'm going to wipe these out. I don't need that. Okay. Does everybody have a setup like this? Everybody has a setup like this?
I'll do it.
Oh, you can just like highlight, grab some cells down here, and then pull them up to here, see? And then it just wipes them out. We don't need those. I never use that stuff. Okay. All right, now we're gonna fill in the information, right? What are the degrees of freedom of the regression? Annalena, what's the degrees of freedom of the regression? In Excel, 1, right? You see the one right here, Annalena? Right there. What are the degrees of freedom of the residual? 46, right? What are the degrees of freedom of the total? So all I gotta do is type in your information, right? 47. Now for the sum of squares, you probably want to copy it. I'm gonna do Control C, then I'm gonna click on this and do Control V. V is in victory. Victory! Win, victory, right? V is in victory. Because we're squaring, Jaina, we're squaring the differences between what we observe in total cost and what we predicted. And so when you're squaring like 500 minus 200, that's a big number, right? You square that and then you sum it. That's why the numbers are so big. But just go ahead and fill in the information as I'm doing it. Got the wrong one here. I'm just Control C, Control V as in victory. Mean square error. Mean square due to regression. Residual, sorry. Let me know what a big F statistic means. This right here, this is the p-value. You guys see significance F? Everybody look where find significance F in Excel. Does everybody find significance F? What does that significance F mean? That's a p-value. That's an area under the F distribution, right? We gotta get the intercept. You gotta get the units, you gotta get the slope. So here's the slope of the line. Need the standard error. We need the standard error of the slope of the line. We need the t-stat. Does the t-stat sound familiar? Does the t-stat sound familiar? I'm just copying them in as I see them, right? Hit enter. What's the coefficient of determination equal to? Does anybody remember what the coefficient of determination is equal to? We computed it in the previous questions. The coefficient of determination is the R square. What's your R square equal to? Mine's equal to 0.0579. Right? Now, if I hit enter, what's going to happen? This is really cool. Notice what happened here. Oh, look at it did. It changed the 0 to what? When I put my R square, when I put my R square into here, it changed this from 0 to what? 0.79. We multiply that by 100. Everybody see that? You multiply the R square coefficient of determination by 100. This implies that 5.79% of the variation in what? What are we predicting here? What's the thing that we're predicting again? Are we predicting units produced, or are we predicting total cost? Yeah. So only 5.79% of the variation in total cost is explained by the model. Is that very good? Does that sound like it's a good thing? 5% of the variation. Wouldn't you want that to be closer to 100%? right? You went out there close to 100%, weren't you? So this is total cost. Yeah. Have we got the green check marks for all that? Regression one? Yeah. Oh. You want to just click on it? And then Control C. Don't click in it, click on it. Right. Whoop, wrong cell. There you go. Does anybody know how we can calculate the t-stat here? We have the slope here, right? My slope is 11.5906. My standard error is 6.8951. What do you think the t-stat is? If you had to guess what the t-stat is, what would you guess it is? Give these two values. 1. I have a slope of 11.5906, right? I have a standard error of 6.89. And my t-stat is 1.68. Almost 2. How do I get the t-stat? What do you think? It's almost 2. Is this almost 12? Close to 12. Is it kind of close to 6? If I took the ratio of these two, what do you think it'd equal? Yeah. Remember the test statistics we calculated for the difference in means? We took the point estimate of the difference divided by the standard error, right? If our hypothesized value is 0, and we want to test whether this is 0 or not, then our point estimate of our difference is this minus 0, right? This minus 0 is this. Divided by our standard error is our test statistic. And this is the p-value that corresponds to it, right? What we're testing is whether this slope is equal to 0. Equal to 0 means what? Two-tailed test, right? Two-tailed test, lower tail, upper tail, remember that? This is a p-value in a two-tailed test. This right here is the probability of being greater than this value. But because it's a two-tailed test, we multiply that probability by 2 to get that value. Right? Remember that from hypothesis testing? It's supposed to be a review. Right? Hopefully these questions won't happen next year when I'm teaching about this in the fall and people take this class in spring. It won't be the first time you've seen it. Right? Not your fault. Not your fault. But yeah, this is supposed to be review, right? This is a two-tailed p-value. The probability of being greater than this is half that. So we multiply that probability by 2 to get that value, right? Now, if I were to test at the 5% significance, would I conclude this is 0? Or would I conclude that this is not 0? If my significance level is 5% and the p-value is almost 10%, right? I would conclude that this is 0. Right? Y'all see it? The p-value is big. When I say the p-value is big, what do I mean by that? It's bigger than your significance level. Right? When the p-value is bigger than the significance level, then we conclude the thing we're testing is 0. So although it says 11.5906, we're going to conclude that it's 0. Right? Statistically, this minus 0, that difference is insignificant. This minus 0, that difference is insignificant because the p-value is big and the test statistic is inside the hump of the distribution. Remember that? Now, if I squared this, Everybody square your t-stat here. Use Excel to square your t-stat. Tell me what you get. Everybody square your t-stat. Everybody remember how to square? I'll show you how to square right here. Everybody square your t-stat. We'll put it right here. So in this cell here, right below the t-stat, type equal, click on your t-stat. Mine's 1.6810, right? Everybody got that? Everybody got that? Yo! Everybody square in their t-stat? Type equal, and then click on your t-stat. And then do shift 6. What am I doing here? The square it, right? All right, when you square it, tell me what you get. Emmanuel, what is your t-stat?
33,
What is your f-stat? What's your f-stat? Oh, make it 4 decimal places too. What's your f-stat?
51.
Are they the same?
Yeah.
Annalena, what's your square root t-stat? 11? 11? What is your f-stat? Okay. Julia, what's your t-stat squared? What is your f-stat? Same, right? Jane in here? Jane, oh, there you are. Okay, I couldn't see it. Jane, what's your t-stat squared?
3.5.
What's your f-stat? Your f-stat?
5.726.
Same?
It's off by the,
Well, rounding the same, right?
Can we say that the F is equal to this time?
Well, I'm gonna get to that in a second. Jacopo, what's your t-stat squared?
It's 4.4493.
And what's your f-stat? Okay, Juan, what's your t-stat squared?
4.96.
And equals your f-stat? Okay. Do the p-values or the p-value of your f-stat, are these two p-values the same in your problem? Are those the same? These two right here. Are the gray highlighted values the same? Annual. Are they the same?
No.
The mine's 0.0995 and 0.0995.
Yeah.
The same?
Yeah.
Julia, p-value is the same? Annalena's p-value is the same? Jana, p-value is the same?
Yep.
Jacopo, your p-value is the same?
Yeah.
Juan, your p-value is the same? Why is that? This is simple regression. In simple regression, how many x's do we have? How many x's were we using to estimate total cost? How many variables did we use to estimate total cost? How many variables did we use to estimate total cost?
Okay.
What did we use to estimate total cost? Everybody? We estimate total cost with what? In a priest. So our equation is this, right? We have one slope, right? We have our units produced. We have our total cost. We have an intercept and we have a slope, right? Right? So in simple regression, our null hypothesis is that for a slope test. For the model test, we have the same hypothesis, right? They're two-tailed tests, right? Now, if our equation had an extra variable, if we had 2 variables instead of 1, then we'd have 2 slope tests, right? And for a model test, we have this. This is our model test. You see the difference? So if we have multiple regression, if we have two X's, we have two slope tests. We have one model test. We use the F statistic for this, right? The F statistic for this. We use the F statistic for this. We use a t-test for this and a t-test for this. We only have one variable over here, so we only have one t-test. You see it? And that's why the t-squared equals F, and their p-values are identical, because these are equivalent tests statistically. So in simple regression, the t-distribution squared is the F distribution. That's how you think of it. When you square the t-distribution, you get the F distribution in simple regression. The p-values are identical, right? Good review?
Yeah.
It's supposed to be a review. All right. So is that a good thing right here? Why is this number so small? Why is that number so small right here? Let's go back to our chart. Look at our chart here. If we do this with one chart, what do we get? I'm going to get rid of line here. I'm going to do all 48 here. See this? I'm going to do all 48. I'm going to right click, add trend line. I'm going to make these all black dots. Okay, this one I ignore. Why's there a line around that? There it is. This is all 48, right? Notice that the numbers match up. You see that? Notice the numbers match up here. This is 1 through 48. The R square is the same, right? Everybody see that? The R square is the same. What about the slope and the slope and the intercept? My intercept is 22,248, and my slope is 11.5906. Everybody see that? Look how much variability there is around this line. Y'all see that? Look how much variability there is around this line. A lot of variability, right? That old machine is got a lot of problems. But with my new machine, what happened? With my new machine, I got a really small R, I got a really big R square, right? So down here, I want to rerun the regression. I want to run the red regression down here. I want to run the red regression down here. Okay, so I'm going to redo the regression. Everybody click on data. Click on data analysis. Regression should pop up, right? Regression should pop up. Click OK. Now, what do I want to do with my numbers here? Where does 19 start? 19 starts in row 20, right? Oh, that's fine. We'll do 20. I'm gonna do 20 down here, right? Oh man, this sucks. I'm gonna escape. Hang on. I gotta move this out of the way. Let's do this. Hang on. Hit escape, get out of the regression thing, right? I'm gonna copy this and everything down below it, right? 19 down to 48. I'm gonna put the labels right here. Yeah. I'm gonna copy the labels and put them right here. Right. So in columns D, E, and F, I've got rows 19 down to 48. You see that? Everybody got that? In columns D, E, and F, I got rows 19 to 48. Everybody got it? Any questions on that? All I did is I went down here in cells, in rows 19, where it says month is 19. And I went to the bottom to the month that says 48, right? I just copied that right here. Copied that right here. Then I moved the labels. I copied the labels and put them over D1, E1, and F1. Does everybody's spreadsheet look like that? So 19 to 48, then I put month, units, and total cost. Good? Good, everybody? All right, now we're going to rerun the regression, but we're going to use columns E and F instead, right? So let's go to data analysis, regression. You want to get rid of Y input range and X input range, right? Empty the Y input range and the X input range. Empty those. Did everybody empty them? I'm going to slow down. Let me know when you're ready to go. Annalene, you good? Julia, you good? Janie, you good? Emmanuel, you good? Are you right here? Okay. Jacopo, you right here? Oliver, you here? Okay. Do you have columns D, E, and F looking like mine? Do you have rows 19 down to 48 here, right? You have that? Okay. All right. Man, you're good? All right. What we're going to do for Y input range. You're going to do total cost, right? Click on F1 and then go down to F31. You have 19? You got it? What label, what are your labels in, Juan? What row are your labels in? In D, E, and F. Are they in row 1? Okay, you got it fixed? Okay. All right, so everybody's got in cell D1 month, cell E1 unit production, unit produced, and then F1 total cost. Oh, 31. Yeah, that's fine because month 48 is in row 31. Right, 48 is in row 31. No, 31. No, this is month 30. This is row 31 on the spreadsheet. All right, Oliver, you got it? You got it? Okay. All right, so Y input range, right? We're going to go total cost, F1 down to F31, right? F1 to F31. Everybody got it? X range. E31 up to E1. So you got E1, E31, F1 to F31. Make sure labels is checked, right? Labels is checked. Output range. We're not gonna put in H1. We're gonna put it. We're gonna put it in H. I'm gonna put it in H21. I just put a 2 between the $sign and the 1. So I'm gonna put it in H21, right? Because I don't want to cover up my work, do I? I want to cover up my work. And then just hit OK. Now this is the red regression, right? This scatter plot right here goes with the first regression. It's rows 1 to 48. This one is all of the data, 1 to 48. What's this one down here? This is the red equation, right? The red dots. I see a red dot and I want to paint it black. You guys see Saturday Night Live? Do you guys see Saturday Night Live? Kevin Bacon imitated what's his name from the Rolling Stones? I see a red paint and I want to paint the paint black. Paint. So this is the red regression down here, right? How many observations in this regression? There's only 30 here, right? Why is there only 30? Why is there only 30? Because we got rid of cells or rows 1 through 18, right? 19 to 48 is 30, isn't it? If we count 19 to 48, we got what? 30. That's the count, 30, right? There's 30 rows for month one, including month 19, all the way through to month 48, right? There's 30 months. Oh, how do we get the 4 decimal places here? Hold the control button down, right? Hold the control button down. And then this number of decimal places to 4, right? What happened to the R square? What happened to the R square, Jacopo? What happened to the R square? Is it much higher than it was previously in the previous regression? In the previous regression, what was it? Yeah, major. Why is there a major improvement? Look at the red line. Look how close it is to the red dots. Look how close the red dots are to the red line. If those dots are on the red line, what is the R square? Jana. If the red dots are on the red line, what would this R square be? 1. Wow, they're good. I didn't expect anybody to answer that. Awesome. That's cool. All right, class is over now. Great. I felt really good. If all the red dots are on the line, this R square here is 1, and that's 1. Right? So this fits the data better, doesn't it? Why? Because it's a new machine. There's less variability, right? We might have done something else. We might have had, at the same time, we might have adopted better analytics. We're not overproducing stuff, right? Part of our cost is our inventory, right? If we have lots of inventory, our costs are going to be higher. So maybe the machine and our analytics combined together mean we have smaller, more manageable inventories that cost less, right? So now what you got to do is you got to fill in the information, right? So you just got to fill in the information now. And you guys know how to do that, right? When I ask my son Wes questions, Wes answers in the most direct way possible. And almost all the time he is honest. Wes, do you like grandma's top ramen? No. Do you like dad's top ramen? Yes. So when Jana said yes, it reminded me of Wes saying yes. Wes is a funny cat, man. He's home from school today because he got in trouble yesterday. He got in a fight with 4th grade girls. Well, Wes doesn't like it when people break the rules, and so he likes to enforce the rules for the school. You know, if somebody comes in the classroom who's visiting, he'll tell the person to leave. We're learning. You're interrupting our learning. When girls are running in the hallway, he'll catch them to stop them from running because it's against the rules to run in the hallway. He's one of those kids that just beats his own drum. I think he has this hyper need for like everybody following the rules. Yep. Come here. Yeah. Oh, you want to use this? Yeah. I'll highlight them all. Yeah. You might go to number. You want to change the number. Well, you have to get a lot of wide. Go back and forth. Back and forth as completes. What's up? Yeah. Oh, does any have a number with an E in it?
Yeah, he has 0.02.
Scientific notation. So if you have scientific notation, it looks like this, right? So the way you fix that, does anybody have E's in your number? I'll show you how to fix it. Okay, I'm going to change this to scientific notation. All right, see that? I got scientific notation here, right? Does anybody have scientific notation and want to fix it? Everybody with scientific notation right here, right? E to the minus 15. Does everybody see that? E to the minus 15? The way you can fix it is you got a number here that's not scientific notation, right? Highlight all these numbers, not from the one with, not that, but click on one that's not in scientific notation. And then highlight all these, see, Emmanuel? I started here, and then you can just do number, and then you can change the number of decimal places. And that will automatically set all of them to regular numbers. Right? Got it? Okay. Sum of squares are large again. Why? Because what we're predicting are large numbers. And their differences from the predicted values is large. And when you square them and sum them, you get even larger, right? Is your p-value of your f statistic equal to the p-value of your t statistic for your slope coefficient? Is the t-stat the square, when you square your t-stat, is it the same as the f statistic? But here again, we're doing simple regression, right? When you square the t-stat units produced, you get the F stat for the model, right? That's only because we're doing simple regression. What is one? Oh, because there's only one variable in the model. If we had two variables, everybody, why is this one right here? Good question. Why is that one? Why is the regression degrees of freedom 1 in both models? Why is the regression degrees of freedom 1 in both models? How many variables are we using to predict total cost? What variable are we using to predict total cost? Units produced, right?
Yeah.
There's only one variable, one X variable that's being used to predict total cost, right? Hit enter, we should get all green check marks, right? And the R square you can get from the chart, or you can get from the regression output. I'm gonna get it from the regression output. Now, when I hit enter here, what happens? It's gonna happen to 0 there. When I hit enter to submit this, what's gonna happen here with the 0? Can anybody predict that? What happens when you hit, after you put the R square in, and you hit enter, what happens to the 0? What does it change to? 47.48.
Yeah.
It multiplies it by 100. Right? That's a cool little trick I learned playing around with my own math. So when I hit enter here, that'll take me to this times 100. Right? So what does that mean?
It's 47.
So this implies that 47.48% of the variation in what? What are we predicting again? Total cost. So 47.48% of the variation in total cost is explained by the model. That's better, isn't it? Why is that? Graphically, why is that better? Look how close the red dots lie to the red line. Everybody see it? The red dots lie really close to the red line. Better than this model here, right? Why are these points so far off? Because we installed a new machine. A new machine that makes less mistakes, right? It's more efficient, makes less mistakes. Mistakes are costly, right? If you have an old, glass furnace, right, and it's old and it needs to be retired, you're probably gonna have more impurities in the glass when it cools, right? But if you have a brand new furnace, you're probably gonna have less impurities in the glass, right? So what does Barney say on How I Met Your Mother? Well, he says legend, wait for it, dairy. But he also says something else. New is always better. He says a lot of stuff, right? I love Barney. Yeah, he's a character. I haven't seen that show in a while. I think it's on Amazon Prime. All right. So we done yet? Okay, at 1% significant, I gotta fix that. There should be a percent symbol there. We'll take a break after this. Yeah, we should have a percent symbol here. Okay, at 1% significance, conduct a following test on the model you adapted to forecast total cost. Right? Notice my null hypothesis is beta equals 0. Beta is the true slope. Do we know the true slope? Can we ever know the true value of a parameter? Are we God? We're not God. We can't know the true values of the beta. The betas are Greek letters, Greek standing for God, God letters. We can't know beta. We estimate the slope by each of us gathering data over a 48-month period of time, right? So this is our null hypothesis, right? At 1% significance, adopted. Are we going to adopt the first regression or are we going to adopt the second regression? Which one are we going to adopt here? The first regression, the R score was really low, right? And this was insignificant. In the second regression, our R square was really high and our coefficient was highly significant, right? So we're going to adopt the second regression, right? So what am I going to do here? How many people have a p-value that's close to 0? Annalena, what's your p-value of units produced? What's your p-value of units produced in the second regression? The p-value, the probability value. Oh, whoops. I got a typo error. I got a typo. This should be p-value. And this should be p-value. Sorry about that. We got to reload it. So delete a 0 from that t-stat for units produced. And then you can reload it. Then you got now it's got p-value there, right? Sorry about that. This should be p-value. That's the last column. The p-value for units produced in regression 1 is quite large, right? At least it is for me. The p-value for regression results 2 is quite small. It's really close to 0, right? Annalena, what's your p-value for regression 2 for units produced? What about yours, Julia? Emmanuel? Jaina? Oliver? Okay, and then Jacopo? 0, 0, 0? Okay, you won. Okay, so all of our p-values are tiny. What does that mean about our t-stats? What does that mean about our t-stats? This t-stat right here. Or are these big? Are these t-stats considered big? They're in the tail, right? We're way out in the tails. Is the difference between this and 0 significant? Yes. The difference between this value and 0, that difference is not insignificant. This t-stat is not inside the critical values of the test. This is way out the tail. When this value is way out the tail, this p-value is really close to 0, then we can say this is statistically different. Statistically different from 0. Its difference between it and 0 is significant. Right? This is a significant coefficient. Right? So what are we going to do? Are we going to reject the null? The null is that slope of 0. Are we going to reject the null? We're going to not reject the null. We're going to reject the null, right? This is not 0. We're saying this is not 0 because this p-value is so big. I mean, sorry, so close to 0, right? The p-value is really close to 0. Our t-stat is big. We're way out there, right? This is like Mozart. Mozart's ability in music is probably 5, 6 standard deviations above the mean. Right? 5 standard deviations above the mean is really like 1 in a billion, right? I think my p-value was 0.000 14 zeros. Right? Like 1. 14 zeros and a 1. That's like 1 in, I don't know, a billion trillion. That human being with a t-stat of 5 is really extremely rare. We're talking about Mozart t-stats. We're not talking about a Hal t-stat. We're talking about Mozart t-stat. Hal's 1 in 1,000, right? Not pretty common, but Mozart is very rare. This is a t-stat of a Mozart, right? So what that means is this is significant. Mozart was a significant figure in history, right? He has a t-stat of 5. He's significant. Probably the greatest musician on the planet ever, right? He's significant, right? He's significantly greater than average. Right? So this is significant. So what we're going to include is this is not 0. Okay? Mozart wasn't a 0. This coefficient is not 0. This is a Mozart coefficient. Mozart was not a 0, right? I would say Jesus has a t-stat of a massive proportion too, right? The dude changed time. He separated the calendar before Christ, after Christ, right? Now they call it BCE. Jesus was a substantial human being, man. Whether you like Jesus or not, whether you worship Jesus or not, dude was freaking impressive, right? These are not 0 people. This coefficient is not a 0, so we're going to reject, right? Reject the null. Which implies that units produced has a what? Again, this is a significant person, right? Is the coefficient positive? Yeah. So it's a positive, significant effect on total cost. The F statistic in the ANOVA table implies that the estimated model is significant. And this is the equation, right? This is the equation. That's the intercept. And this is the slope, right? Now we're doing what? We're deploying the model. We're deploying the model, right? In the course of history, I'm going to be an insignificant person. Nobody will remember me in 100 years, right? I'm cool with that. I'm insignificant. In the course of human existence, I'm basically an average person. I'm insignificant. Total cost? Units produced has a significant positive effect on total cost because this is positive and this is not 0. This is a significant number, right? And then it's the intercept here and the slope here, right? Use the equation to predict the firm's total cost in month 49. How are we going to do that? The marketing department. Sorry. The marketing department. I got to add that. Okay. So I'm going to refresh and resume. The marketing department expects to sell how many? Everybody's got 450 here, right? What are we going to do to figure out how much the total cost will be? What are we going to do? Are we going to replace this with 450? You see that? Not 49. In month 49, we think the next month, right now it's 48, right? Next month is the 49th month. The next month we expect what? Yeah, the next month we expect what? In month 49, we expect to sell how many? 450, right? How do we find that number? How do we find that number? We have to multiply 450 by what? By the slope, and then add that to what? Into their intercept, right? There's two ways you can go about doing it. You can copy this, you can copy that from the chart, or you could just do this. Equal 450, month 49, take 450 times what? The slope, right? The slope plus the intercept. Yeah. So on the end of my DEF, I added a row of 49. It's not month 49 yet. We're in month 48, right? In month 48, we estimated this equation. Next month, marketing tells us we're going to sell 450. How do we project our cost? I'm taking the 450, right? E32, that's E32. I multiply it by I38. I38 is the slope coefficient, right? And then I'm adding to that product the intercept. Okay. This is why I love this method, because you have to be engaged, right? You can't look out the window at the beautiful skyline of New York City. Learning is going on as we speak, whether you like it or not. Isn't that cool? You can't just take notes and not think about what you're doing, right? You actually have to do stuff. Right? You have to calculate things. You like this, or would you rather have me lecture and have a test?
Well, that would be,
This class would be horrible test, right?
yeah.
Yeah. Why? Oh, this is business. If you're doing the reading and you're paying attention to the context of the problems, yeah. It's about business, right? It's about business. What do you think you do in the business world? You're gonna be playing with data. You're gonna be doing data in the business world. Management is math. Operations management is math. At least higher levels, right?
You say maybe nowadays instead of doing that, they use systems.
Yeah.
We just enter data and system.
Yeah, but you gotta be really careful if you have that kind of system. I had a PhD candidate come up to me one time. He's trying to do a test or a chi-square test. And I'm like, what's your data? He couldn't tell me what the data was. And he's throwing garbage into a statistical package. He's a PhD candidate. I go, dude, do you even know what you're doing? I didn't say it like that. But I was asking him questions about what's the twisting your hand in chi-square test. He had no clue, just throwing information in the end of the model. His data was all messed up. He wasn't throwing counts into the test. A chi-square test uses frequencies.
How many of you to do
Okay.
it?
All right, did everybody calculate it? Did everybody calculate this? So when marketing tells you we expect to sell 450, what are you gonna tell them? I don't understand. You want to know, your boss wants to know how many people to put on the production line, right? Your boss wants to know how much to put on the production line. If you expect to sell 450, you want to know how many people to put on the production line so that you can make 450 units, right? And you also want to know how much that costs.
Another question.
Yeah.
Is it possible that the result of the equation is lower than the one above?
Well, it should be more because 340 is down here, right? 450 is up here. So it should be up higher. Is this 340? Is your number here smaller or bigger than 450? What's your number in row 40 in month 48?
So yeah, 450, which is 32. That's why 38, which is the biggest product, right? It's 14.32. And
I haven't hit enter yet. But what is your quantity sold in month 48? What's your units produced in month 48?
257.
So this number should be bigger than that. Because your slope is positive. Yeah. Should be positive.
Yeah, if you look at it also, for example, on the
Oh, the reason why it's not though. Sorry, did I let yell too loud? The reason why it's smaller is because this is what we expect to see. These are numbers that we observe. These are numbers that we observe. And what we observe and what we predict are two different things. Right? If I do the same thing on 340, what happens? If I change this to 340, what happens? Jana, this is why there's a problem, right? With the sum of squares.
is more.
See that? If this is 340, we expect our total cost to be 23,690, right? Yeah. This is what we expect. This is what we observe. Is there a difference? Yeah. That's the error in the model. Right? And when you square that error, you get a sum of square error. Those big numbers, right? These models aren't perfect, are they? And you know what round Tom Brady was drafted in? He was one of the last people picked
Yeah.
for middle, 6th round. Yeah. What does that mean? That means the model they used to value him as a player under predicted his value, right? So what do we observe with Tom Brady? That. What did the draft evaluated Matt? They predicted him here. The difference in those two is the error in the model, right? What we observed, right, in reality, and what we predicted with the model. We predicted him to be an average quarterback in an average year, right? He ended up being the greatest of all time. So this is what we predicted, this is what the model said, and this is what he ended up being. Ryan Leaf, and you know who Ryan Leaf is? No, you don't, because he was a stud quarterback at Washington State University, almost beat Michigan single-handedly in the Rose Bowl '97. He was the second person picked in the draft. Second person. Behind Manning, right? Peyton Manning. His observed value was down here. He threw 21 interceptions and 7 touchdowns in his storied 3-year career. He's famous for yelling at reporters in the locker room because they asked him why he sucked so bad. Right? He threw the chair and screamed at the reporters. So we observed how bad he was, but the model projected that he'd be really highly valuable quarterback, right? Error in the model. This is the error in the model, right? So if we sell 300, if we produce 340, we expect the cost to be 23,690. But what we observe is 25,682. There's error in these models, right? You see that? Now, when you project into the future, how much does the error grow? Have you guys ever seen the cone of a hurricane on the news? When they're talking about a hurricane hitting Cuba, right? There are hurricanes down here in Cuba. They drop like this, right? The hurricanes down here in Cuba. In one day, they expect it to be here, right? In 2 days, they expect it to be here, right? What happens to the prediction cone as you get further into the future? It gets wider, right? The further into the future you get, the bigger the error. We haven't observed this, right? We haven't observed it. We're predicting 450, right? We're predicting 450. But what could happen next month? What did the Saudi Arabians just do yesterday? They announced what?
They're changing
They're restricting output of oil to do what to the price of crude oil? To raise it. Did anybody expect that? Nobody expected it, right? So what happened to your next month's cost? Next month's cost of making gasoline just went way up, right? $8 a barrel. We hear new news, right? That new news wasn't in our model yesterday. Today it's in our model, right? So now in our model today, we got to update our model. This is about all about analytics, data and analytics.
About Russia, China, South
Yeah, they're all getting together and they're going to trade in their each other's currency. Yeah. Right now, commodities, before a couple of years ago, most commodities in the world were traded in dollars. Yeah. We had the reserve currency. Now they're changing, right? If you want to know what the effect of that, take my international econ class in the spring or the fall. International econ. If we lose the reserve currency in America, that means people who don't want to hold dollars, they're going to end up, all those dollars that are being held overseas accounts, they won't need them anymore. The demand for the dollar will fall, right? And those dollars will come back to the United States. And for people who live in the United States, we have a lot more dollars sloshing around. And what do we learn from all the dollars that the federal government under Trump and Biden printed? We're going to have inflation, right? If we lose the reserve currency overnight, we'll have lots of dollars sloshing around this economy on a lot of inflation.
What course you mean? International?
What?
Because name is international one.
International economics. Yeah, we're going to talk about that stuff in international economics. I've never talked before, but I'm an economist and I like economics, so it's gonna be a lot of fun. All right, so we're predicting that cost, right? I'm predicting this cost. And all of us are different, right? Why are we all different? Because we all have different data. We all have different subsets of the data, right? We don't know the truth, do we? We don't know what the true value of the slope is. We've estimated with our sample of data, right? If I were to go around and ask everyone what their slopes are, let's start over here. Emmanuel, what's your slope? 11, 12.
Yeah.
We'll round it to 0 decimal places. 12?
Yeah.
And Alina, what's your slope? 15? Mine's 15. Julia, what's your slope?
14,
14? Jane, what's your slope?
18,
Juan, what's your slope? 14? Jacopo, what's your slope?
14.83.
14. Oliver, what's your slope? We all have different numbers, right? What do you think the truth is? When you watch Fox News and when you watch CNN, do you think Fox News tells the truth? No. Do you think CNN tells the truth? No. Because most of what Fox focuses on how bad the Democrats are. You watch CNN, all they talk about is how bad the Republicans are. Right? Now, I would agree with both of them that they're both bad. So the truth is probably somewhere in between, right? The truth is probably somewhere in between. They're not telling you the truth because I don't believe a narrative where everything Republicans do is bad, or everything that Democrats do is bad, right? I just don't buy that at all, right? So the truth is probably somewhere in between. Given all those numbers we just reported, where do you think the true slope is? 13? In the middle, right? Who knows that value? Only God knows that, right? Only God knows that value. We are gods. We are gods. We're mere mortals. What do? We can ask God to tell us what that value is, but he's not going to tell us that. God's just going to go, you didn't pay attention in STARS class. So I'm not going to tell you, right? If you didn't pay attention in STARS class, then you know how to estimate it, right? Okay. So this number is going to have error in it, right? This number's going to have error in it. But it's our best guess. We're not gods, right? Nietzsche said, I think Nietzsche said this. I think he was an atheist. And even Nietzsche, an atheist, said, everybody needs a God in their life. Why does everybody need a God? We start thinking we're God. And gods can't sin. Gods can't make bad decisions, right? That creates a moral hazard. And you end up making some really horrible decisions like what they're doing at Silicon Valley Bank, right? Silicon Valley Bank had all kinds of moral hazard. Created by the Federal Reserve, in my opinion. All right. So I'm saying we're going to have a total cost of what? Let's see, the total cost. 2 decimal places. Now to keep beginning inventory equal to ending inventory, how much do you have to produce? Right now we have, I don't know, 12 units of inventory. If we expect to sell 450 and we produce 450, right? And all that pans out, how much ending inventory we're going to have? 12. So it should be 450, right? If the marketing manager increases its sales forecast by 1 unit, how do you do this? Everybody look right here. How do you do this one? I'm going to go and come down here and do this. 451, right? I'm going to change this to 451. I'm going to copy this equation right here, right? I'm going to copy that. I'm going to put it down here. Now, what do I have to do with this 450? I have to pull it down, right? So if they modify their estimate of what we're going to sell next month by 1, what happened to my total cost? How much do you think it increased by? If you had to guess exactly without doing subtraction. If you had to guess exactly, I'm going to say without doing a calculation, I'm going to tell you what the difference of the two is without doing a calculation. Y'all ready for it? It's 14.9285. The difference in these two is 14.9285. Juan's going, dude, how do I know that? What does the slope tell you of a line? What does the slope of a line tell you? If I increase my x by 1, my y goes up by the amount of the slope, right? So I can either add this number to this number, or I can recalculate this number with 451, right? That's what the slope tells me. Yeah, everything in the corporate world is data. Corporations are collecting all kinds of data on every consumer on the planet. When you purchase stuff with your laptop, it's all data. They know if Jacopo is a 1-click buyer. They know that I'm a 1,000-click buyer. I will search and search and search for the lowest price possible for a product. Right? And they know that because I do that on my laptop anytime I search for airline tickets or anything. I will not buy until I've clicked 1,000 things. Right? And for that reason, when I do a shopping search on Google, they probably give me prices that are probably lower than 1-click shoppers. 1-click shoppers, they know they'll search and buy, which means they have a higher willingness to pay. A 1,000-click shopper has a lower willingness to pay. So when I shop on my laptop, I probably get lower prices than everybody else because of my shopping behavior. My IP address of my laptop gives me away. I'm a 1,000-click shopper. Maybe, but they might notice that you're using your credit card. But the cool thing is they would have quoted it based on my IP address. They won't know it until after, right? And they can't change the price. Yeah. Any questions on that? That's kind of fun, right? So the forecast goes up by the intercept, right? The forecast goes up by the intercept.
I don't understand how you did it.
Yeah, I'll show you. There's 2 ways to get it. There's 2 ways to get this number. I can just add 14.93 to my previous prediction, right? Because I'm doing one more. What is the cost if marketing says, oh, sorry, we can sell 451 units next month, right? The marketing says we can sell 451 instead of 450. I can take my previous estimate and just add 14.93 to it. When I add 14.93 to this, I get that number. Or I just recalculate this number.
Okay.
Yeah. See right here in the manual? I took the quantity, multiplied by the slope, and then I added the intercept, right? Down here, what did I do? I took this new quantity, multiplied by what? The slope, and then added this intercept, right? Yeah. The difference in the two cost estimates equals, oh, wait a minute. I think I'm missing an answer box here. Hang on. Oh yeah, I'm missing an answer box. There it goes. You'll need to do a refresh on that. Click the refresh button up here. Click the refresh button. Resume. And then go to question 3. There you go. The point of this question is to have you understand that the difference in the values is the slope, because we increased unit produced by 1, x goes up by 1. What happens to total cost? It goes up by the amount of the slope. Right? It goes up by the amount of slope. This class actually is going to be a feeder into business analytics. That's how I designed this class. I want students to take business quantitative methods in the fall, take this in the following spring, in their sophomore years, and then during their junior year, second semester, they can do the business analytics boot camp, or they can do that in their senior year. So this is a feeder class. This class also counts for your ITS elective. It counts for your ITS elective. Yeah. If you don't want to do business analytics, you do this class, it counts as your ITS elective because of the coding nature of it. Right? Because we lost accounting with computers. Right? But I also want this class in business quantitative methods to get people prepared if they want to do business analytics to satisfy all of their business electives. Right? Julia, you do that, right? You do that, you're doing the boot camp? Maybe, okay. That's cool. You don't have to do it. I'm not going to force you. I'm not going to point a gun at you and say, you must take the business analytics boot camp. Okay.
I took the mix was right.
Huh?
The last one. Yeah.
Let me check it. It should be the intercept, the slope coefficient, right? Rounded to 2 decimal places. So I need to make that 93. Hey, 1492. What did Columbus do in 1492?
Oh no, I meant the second one, Mark. I must have been.
Oh. What did Columbus do in 1492? Sail the ocean blue. I need to go buy a lottery ticket. I need to make that 1493. So when you submit it for the last time, if you haven't filled in this number, this is the slope coefficient, right? Jana, did you get a problem with your second number?
Yes.
It should be higher, right? See right here? The predicted value will increase because we're going up the line, right? Going up the line. So this, right, this number here is 451 times the slope plus the intercept. Yeah, dudes, I'm telling you, data companies are data. Marketing is going to data. They're using marketing analytics a lot in marketing. Marketing analytics is actually pretty cool. I love to teach marketing analytics. There's a thing called LIFT. It's really fascinating. It's ratios of probabilities. Yeah. This class should be pretty cool, right? Because there's no test. We do the homework in class. So as long as you're in class doing the stuff, you get a good grade, right?
Yeah.
That's all you have to do, right? I mean, I could lecture and then just have a new test, but I hate testing. You know what I hate reading? I spend hours programming a problem to point out and read it.
Okay, so you didn't multiply.
I did with this one.
Oh, no, so let's do this.
Okay.
I think. Click on the 451, then times. I think click on the slope. The slope, and then plus the intercept. And that should be. That'll be the second one.
Here?
Yeah. Oh, no, sorry. That'll be that number right there. That's in 451, right? That should be here. Let's fix it. Oh, this is a different number. This is. Oh. Yeah. What's the other regression? Oh, yeah, yeah.
That was silly. That was silly.
Yeah, you- Oh, come on here. Julie, you good? Okay. All right, you guys want to submit it? Yeah. You good? Yeah, got it?
Yeah, I just.
Good.
Yeah.
Oh, yeah.
It says like 40 or 40 points. See the days for more, but then here says,
Question two.
oh, because of the regression.
Yeah.
Question.
Yeah, you're right.
Yeah, you gotta fix those, yeah. All right. Manuel, you good?
Yeah.
Okay.
Okay, now I'm good.
Everybody's good? Should we take a short break? All right, let's take a short break. Oh, man, that's a short chair. You know what I did the other day, last Monday? I got in my office and I set something down and I didn't realize I kicked my chair back toward my door. And I went to sit in my chair and it ended up on the floor. I ended up on the floor because I kicked my chair out of where I thought it was. And I just almost did that with this chair because it's so low. Let me stop the video.